Okay, so before I start, the usual question: Am I audible? Am I visible? Is my screen also visible? The three questions. Anybody can just give me a some confirmation. Then we can start. So Balaji, maybe you like
Yeah,
to.
we can start. Everything is okay.
So my
Sound is perfect.
sound is
Screen
perfect,
is
screen is
visible.
visible, and I am also visible, right? Okay. So
Yes,
today
absolutely.
we will be covering the chapter called exceptions. So as usual, my book we always talk about the learning objectives. So so there are four learning objectives in the current chapter. LO1, which is understanding the difference between syntax error and exceptions. Then learning objective 2 is to try to use the try except else block of code. So there are three terms: try, except, else. All right. Then understand that Python 2.x, it was possible to derive the exception from two different classes, exception class and string class. But in Python 3, it is possible to derive exception only from the exception class. This is a bit outdated, if I may say so, because when I wrote this book back in 2019, Python 2.x was still in vogue. Some people were still using, but it's going out of. So we will not talk about Python 2.x at all, but we will talk about how to derive exception classes using the exception class. Then we will talk about the various built-in exceptions in Python, such as IO error, end of file error, zero division error, import error, index error, name error, indentation error, type error, etc., etc. So we would like to talk about all these things. So these are the four learning objectives: one, two, three, and four. The first is the difference between syntax error and exception. So let's move towards that. And by the way, I hope you have also, taken out uh, this chapter 15 or 16 of my book, which is about exceptions. So we'll talk about it. So let us see the difference. So there are two distinguishing types of errors, if I may call them errors. These are syntax errors and exceptions. These are the two types. Syntax errors are also known as parsing errors. No, in as I for those of you who are old hands in computer science or in programming, you might understand the word parsing. But for those who are not new, let me tell you that when you write a script, the interpreter or the compiler. I always use the word interpreter and compiler sometimes interchangeably, but for a scripting language, we use an interpreter. And like Java, like Python is a scripting language, JavaScript is a scripting language, so they have an interpreter. But for compiled languages like C++ and Java, it is a compiler. So whenever you write a script, the first thing that happens is whether it is an interpreter or a compiler, it will parse your code. That means it will create chunks out of your code. It will take out the various parts of the code and will try to understand what exactly you are trying to do. But if there is something in the program or the script which is not as per the laid down language specifications, then it will not be able to understand what you want to do, and that is a parsing error. They are generated if the rules for syntax are not followed while writing a script in Python. So if you don't follow the rules, for example, if you're creating a list with item A, then item B, and you're supposed to put a comma between the two. So if you don't put this comma, this is a parsing error. It is not a exception, it's a parsing error, because when the Python interpreter tries to read this list, it will not be able to, it expects a comma between two different items in a list. And if the comma is not there, it will not be able to understand what you're trying to say. It will raise a parsing error or a syntax error. Syntax errors are the most basic types of errors in Python, obviously. They arise when Python parser is unable to understand a line of code. That means, as I told you, that the programming language must always be deterministic. The script outcome must also be deterministic. I gave you the example of a round bracket 3. What would happen? Is my screen being shared? Balaji? Hello? Balaji?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine.
Error versus exceptions, it's said.
Yeah, okay. So I give you the example of 3 and 3, comma. Now this is a number and this is a tuple. So if the comma is not there, the Python will take it to be a number. But if the comma is there, the Python interpreter will take it to be a tuple. So that is why this is syntax. Then syntax errors are almost always fatal. That means there is no way to successfully execute a piece of code containing syntax error. So if your code has a syntax error, you cannot execute it. For a scripted language like Python, you cannot execute it. For a compiled language like Java and C++, you will not be able to compile the language, the source code into an executable code. So it will not work. Most syntax errors are what is called typos. Now, typo is a very common word used in programming. Typos, which means typing errors. Incorrect indentation, example, incorrect arguments. On the other hand, except ye to ho gaya. So this is what I'm talking about here. I'm talking about errors. This part I'm talking about errors. Now let me talk about exceptions. On the other hand, exception is an error which happens during the execution of the program or a script. That means once the interpreter has gone through your script and found no syntax error, it will try to run your script. And during that phase, if something goes wrong, something which it is not able to handle, then it will throw an error which is known as a error. An exception is an event, very important. It's which occurs during the execution of the program that disrupts the normal flow of the program's instructions. So if, for example, suppose you divide a number by 0 and you try to use the result in some calculation. Now, the Python interpreter does not know how to handle the number divided by 0. And this is called the runtime. So exceptions are also what is called runtime errors. See, these are more. This term is more important for language like C++ because in C++ and Java there are two things: a compile time and a runtime. That means the program is first compiled. As I told you, the difference between a compiled language and an interpreted language. In a compiled language, the source code is first converted into a byte code, and that byte code is run again. That means it is done in two phases. The first phase is called the compile time, and the second phase is called the runtime. However, in a scripted language like Python and JavaScript, there is only one time, that is runtime. So that therefore errors in Python are called runtime errors, and syntax errors are those errors in Python which happen before the program can actually run. So this is the difference. In general, when a Python script encounters a situation where it cannot cope with, it raises an exception. So basically, if it comes to something which was like I gave an example, if it tries to open a file which doesn't exist, or it tries to access a web page which doesn't allow access, there can be all kinds of situations where the Python interpreter is unable to deal with the situation. So it will stop the program, but it will throw out something. It will give you some output, thereby to try and tell you what's gone wrong. That is the thing between errors and exceptions. So this is the first part. Let's move ahead. Okay. So I've given you very simple. Let's do this. Let me first explain. So now let me just tell you these three these three greater than sign. This is something which is used in idle. Idle is an interpreter which comes along with Python. It's a very, very poor kind of an interpreter. So I don't use it anymore, but I've given it sometimes in my book. You should not, you should just ignore these three forward arrows for those who are just in my book. If you are getting confused, this is for idle. And this is used in those cases where you are not using Jupyter notebooks, but you're simply downloading. See, I must tell you that it is not necessary that you can only use Python on a Jupyter notebook. As I had explained earlier, Python can be used on many different IDEs, IDE, integrated development environments. And one of them is also idle, which is a very, very poor kind of IDE. Then you have, I told you about VS Code, Visual Studio Code. Then I told you about PyCharm, which is a paid one. And I also told you one about Spider, SPYDER. Now, Spider comes bundled with Jupyter notebooks. I can show it to you. I can just, let me just, I'm maybe digressing a bit, but if you go to Anaconda, so this is the Anaconda folder on my machine. It has got a navigator, it has got a PowerShell, it has got a prompt, it has got a Jupyter notebook, it has got a reset spider, and it's got a spider, this spider, this spider. This is spider. This is spider. The spider is also an ID. Let me just let me just show you what spider looks like. Let me just open it for you guys so that let me just, it'll take a second to open. This is a spider. It comes part of the Jupyter notebook bundle, the Anaconda package. So it'll just take a second to open. Just bear with me. I don't know what's doing. Yeah. So this is your spider. I don't want to go into the details of spider. You can do your own research. The point I'm trying to make is that you can write a script in spider also, something like this, and this is your your shell, and the outputs can come here. For example, let's just run this program. Run. So just let me just show you. So this is a simple script. Its name is temp1. Temp1. It is having a one line print x plus y, and these x and y are two strings. They are two strings. It is giving you an output of x and y over here. So I will not go into the details of Spider, but I'm just telling you this is how it works. In fact, if you want to see the Visual Studio Code also, I can show you on my machine. So let me just give me a second. I'd shown it to you earlier. I think this is Visual Studio Code. So this is, I'll not go into that. So you can do Visual Studio Code. You can do your own research. PyCharm I don't have because PyCharm is a paid IDE. PyCharm is a paid IDE. That means you have to, I think, if I remember correct, some features are open source, but mostly it is paid. So I have not tried this thing. But let me come back to this code, right? Let me just write this on my. Let me write my S. Wait, what is it? My S or my L? Okay, my S is equal to A, B, C, D. Now, if I print my S 0, what should it print? Anyone? An A. So, because a string is also a sequence, and all sequences in Python can be accessed by the sequence name followed by the index, which here is 0. So therefore, when I use the index 0 on my string ABCD, I will get the first item of the string, which is A, right? But now suppose I write my SID, say 4. Now what will happen? Yeah. So now this string has got 4 items which have an index from 0 to 3. A is 0, B is 1, C is 2, and D is 3. So if I try to access the 4th item of this index, right, that doesn't exist. Therefore, string out index out of range error. So it's an index error. It is an index error. That means Python interpreter is telling me, it is also giving me a hint where this error is occurring. That means in line number 2 of my code, this is line number 2. And it is telling me this is an example of the Python interpreter not being able to handle my script. So this just note that this syntactically both these lines of code are okay. There is no syntax error in either the first line or the second line. So this is not a case of a syntax error, but rather this is a case of an error, which is a exception. So this is a case of an exception being raised by the Python interpreter. Let's move ahead. Okay. So, okay. Now, just I want to tell you that in Python there is a inbuilt keyword called raise. Now, in the example I gave you, it was the Python interpreter which raised the exception. When I tried to use MyS with an index of 4, the Python interpreter gave the error. However, sometimes it may be so needed that the programmer wants to raise the error. If you want to raise an exception by using the raise statement, that means you can also raise an error inside the Python script by using the raise statement. And the way it is done is raise exception name arguments. So this is the way it is done. And as you can notice that, let me just show this. Now, okay, let me just show it on code, right? Let me just show this on code. Yeah. I have to remove these 3 forward. Now, what do I get? Just let me show the screen to you. Name error is an inbuilt error of Python. Name error is an inbuilt error of the Python. Inbuilt means it is there. It is not, I cannot use the word exactly inbuilt, but it is one of the errors of which has been created, which exists in the Python interpreter. I will tell you. So name error, the Python interpreter knows what it means, and this message will be given. So if I print the statement, the name error is printed along with the message inside the brackets inside this. So this message also is printed over here. So don't worry if this is becoming a bit hairy, it will become very clear to you. This will become very, very clear. Let's move further. Okay. The try except else block of Python code. Let me just digress a bit. As somebody mentioned to me that one good way of wait. Let me just digress a bit. Let me give an analogy. Suppose you are a zookeeper and you get some animals in a box, right? And these animals could be mostly like, suppose most of these animals are snakes. So snakes might be poisonous or they may be non-poisonous. But you don't know. You don't know what is inside the box. And during handling, you have to maybe put your hand inside the box somewhere, maybe fingers go inside, and the snake can bite you. It may bite you, it may not bite you. So therefore, what you do, When you are expecting a box without snakes, you may not take any precautions as a zookeeper. But suppose you know that this box might contain a snake which may be poisonous, which may be non-poisonous, you may like to go to special room to deal with this box. And in case the snake bites you, you should be able to take certain precautions, right? So maybe this snake is a cobra, maybe a crate, if it is poisonous, or maybe some other poisonous snake. So in your room, you have a anecdote or antidote for cobra, you have an antidote for crate, and you also have an antidote which deals with all the snake, poisons. So what you do is you can do it two ways. You can first try the antidote of cobra and see if it works. If it doesn't work, then you try the antidote for crate. It doesn't work, then some other snake, then other snake, and finally, if none of them work, then you use the super antidote, which takes care of all snake poisons. So this might appear a bit far-fetched, trying to compare code with snakes, but then let me now come back to code. Now, suppose there is a piece of code where you expect that something might go wrong. For example, as I told in opening, files accessing web pages. So there are chances that something will go wrong. So if it goes wrong, then you want to be prepared. You want to have you want to keep that piece of code in a place, in a block of code, so that should something go wrong, you go to a place where you can deal with it. So that is our precise this thing in this try except block. Let me just now come here. So let us, with that background, let us come back. There is a piece of code which might throw an exception. We don't know. It might, it may not. If you're having a function which is say giving the dividend and the divisor, and you tell and somebody gives a zero as a divisor, it'll throw an error. Somebody else doesn't give a zero, it will not throw an error. So it will depend maybe on the user input. So the might throw error, may not throw it. Then the good way to deal with this code would be to enclose it in a try block of the codes, just exactly like my snake example. So if you think that a particular piece of code is likely to create some error, then you would like to enclose that code in a try block, right? The try block gives the programmer an opportunity to deal with the error. So if you don't put the code in a try block and something goes wrong, then the program will halt and the script will not run, error will be thrown. However, if you put that code in a piece of in a block with the try block, then the Python interpreter will give you an opportunity to deal with the exception yourself, to deal with the problem yourself. If you are unable to deal or unwilling to deal with the problem, then the interpreter will deal it in its own way and will throw an error. So if you have a try block and you get an error, the interpreter will give you an opportunity to deal with it in the except block. However, if the script in the except block is unable to deal with the error, then the Python interpreter will stop the execution of the script and raise an inbuilt error. So exactly like this. So like that snake, if you're able, if you have the antidote for that snake poison, great. But if you don't have, then maybe somebody else will take over and the person will probably pop it and the program will stop. So when you enclose a suspicious code in a try block, there are two possibilities. One, it will throw an error exception. Two, it will not throw an exception. So how to deal with this? Now let me just come to this. Let's come back to our code because that is the best way to understand. So the pseudo code is there in my HTML. So this is the try block. It starts with the try keyword followed by colon and then a space of 4 white spaces and then something, whatever code you want to write, you will write over here. So if this code, after this code, there will be an except block. Again with a tuple Now there is a little bit of tuple followed by a colon. This tuple may be there. I will just explain. This tuple may not be there. This is called a tuple of errors. Tuple of errors. Tuple of errors. So all the errors which are given in this list or in this tuple will be dealt with in this except block. And only those errors which are given in this tuple will be dealt in this except block. Just like suppose you had that snake case, you have an anecdote for cobra and an anecdote for some say mamba, which is the most poisonous snake. Suppose you have two anecdotes, but you don't have a anecdote for crate. Then this except block will not be entered because your two exceptions only deal with cobra poison and mamba poison. They don't deal with crate poison. So therefore, also then your except block will fail to be able to handle the problem, and the Python interpreter will take over and it will throw an error. This we'll understand once we do more code. Let us take an example. So okay, let me just first explain what I'm trying to do over here. So I am creating an infinite loop while true. Infinite loop while true means true is always true. So there's no chance of true being false. So this loop cannot be exited, right? And inside the try statement, I have a break, right? Now I am saying my I in integer input, give me an integer. So as I told you, whenever the Python interpreter sees this keyword input, it will stop the execution here, and it will give you a chance to give some input. So I have to give an integer in this box. Let me do it. So let me put 4, which is an integer, and run it. So what happened? So what happened? What happened? Since I put 4 over here, input, it was able to convert this 4 in an integer, which went into my I, and this line of code was printed. So this line of code ke baad ye line print hua, and the Python script exited the infinite this thing, and this line of this thing was printed. You gave an integer, so quit. The except block was not entered. This was a case of a non-poisonous snake. This was a case where the script did not throw any error. Where the script did not throw any error, right? Here is a case where the script did not throw any error because I gave it an integer of 4. So my try block was able to execute without any problems. Now let me see a second case. Let me just run it again. And suppose I print an A over here. Now let us see what happens. Now, had I not put this line of code into a try block, if I had not put it in the try block, then the Python interpreter would have stopped over here. Let me just show you a case where the try block is not there. Suppose I write and I run. It's gone wrong. No. Okay, this is right. Wait. This. Yeah. Okay. So I have done something. I have written another this thing. I am writing this thing. My same line of code is this one, but outside the try block. It is not. It is simply on a single line of code, and I'm going to execute. So now suppose I was to print A over here. So what happened? The Python interpreter threw an error. the Python interpreter threw an error because when I gave an a over here, the Python interpreter tried to convert this a into an int. It was unable to do so. Therefore, it threw an error, invalid literal for int with the base 10 a. So this is what the interpreter gave me when I did not. So the problem here is that I did not enclose my suspicious code, because whenever I'm taking input, there are crazy guys who, if you ask them to give an integer, they'll probably give you a float. If you ask them to give you a float, they'll probably give you a string. So all kinds of people with all kinds of thoughts. It could be a spelling mistake, it could be a typing error, whatever. So here I did not take care of that. So it is the interpreter is throwing an error. But when I run this code, let me just run it again. And when I type an a over here, there is no error by the interpreter. See, there is no error. What has happened now is that, let me see. So I put this a I put over here. The Python interpreter tried to convert this a into an integer. It could not do so. But the interpreter knows that this statement is inside a try block. So it will try to see whether this error can be dealt this here or not. Because this is a value error. This error is a value error, and then it tries print, not an integer, try again. So what is happening? Again, I'll come back here, and again this statement is printed. So if I again put a s, again, no, let me put an s here. Wait, let me put an s here. Again, it's so not an integer, try again. So what has happened? Now I have created a loop, and I cannot exit that loop until I give it an integer. If I give an integer, now I have quitting. So let me stop over here for a second and just take some feedback from you guys, because so are we good so far? Are we clear so far? Any questions, any observations?
Yes, sir. You are on the right way.
Yes, sir. Yes, sir.
So okay,
Yes.
so let me see the comments also. All clear, great, excellent, good evening. That's fine.
Nice,
the
sir.
comments-
Excellent.
So the comments are also all with me. They are all saying that you guys are all with me. Let's move ahead, right? Okay, let's move ahead.
Got everything.
Okay. Now let us talk about this try, except, else, finally block. Try, except, else, finally block with multiple exceptions and except with no exception type. Just this is a very loaded statement again. Let me just highlight it for you guys. So what I'm trying to say is I'm going to now write a program which uses 4 blocks: a try block, an except block, an else block, and a finally block. And I'm going to use with multiple except statements. And I'm also going to create an except with no exception type. Multiple except statements, and also an exception with no exception types. Now let me just let us the best way of doing it is by you know, I think I so yeah. So let me just I modified that program a little bit. So this is my definition. My this program which I've written on the screen right now is a little bit different from what is written in my book. I've tried to simplify it. This is a function I've written, my func. It is taking 4 variables: myl, idx, dividend, and divisor. So what I'm doing, I'm doing 2 things. I'm doing something, and I'm also printing something in this line, then another print, and then another print. So there are 3 print statements with 3 different things. The first one is doing myl idx. So here what I will do is, on purpose, I will give an index which is not there in this. So I will feed this myl, I will feed this here, and I will try to do an index which is outside this, and then let us see, right? Then there is a idx. So myl will go over here, the idx will go over here, the dividend will go over here, the divisor will go over here. So basically, I'm going to be raising three types of errors. This let me just show this. So I'm going to raise three types of error. The first error I will raise from here. The second error I will raise from here. And the third error I will raise from here. I will just show you how it happens. So let me just show you again. Now I am giving a function. I am giving a list ABCD. This has got 4 items. So this list will be feeding in my L. This will go here, and then I'm giving a index of 4. So basically, in this line, I am asking this to print my L with the index of 4, which is obviously an error. So this line of code obviously will be executed, but at this point of time, the Python interpreter will not go down, but rather it will enter the except block. So that is why let us try this out. Let us try this out. Let us try this out. So give me no, sorry. Wait. No, I'm sorry, I didn't go wrong. Let me run this. Now let me just show you what happened. So what I did, I called my function with the my list, which is having 4 items, these 4 items, and an index of 4. Forget about these 2 numbers for the moment. Let's talk about this. So what happened is, and then I enter the try block, print if this is printed, this is printed, index okay, and then this. So this line of code will not be printed. Rather, this line of code will not be executed. This will be called with the 4, which will go to this first error, index error. And here it is index out of range. Index out of range. So this index out of range is printed. Else will not be printed. And finally, exception or not, this will be printed. This will be printed. So this will be printed. And this will be printed. This will not be printed. This will not be printed. This will not be printed. So this is the way it works. Let me just stop here. Let me take you first to the diagram. Then maybe you can understand things better. So this is the diagram from my book. So this is the try block, and there is a suspicious piece of code inside. Now this code may or may not throw an error. So it throws it. So let's go here, error. And there is an error, yes. There is no error, no. If there is an error, then the error might be present in the list. I will show you. If it is present, and then except block is executed, right? So this is this thing, but if the error is not there, then the else block is executed. However, if there is a try except else finally block, then the diagram will be something like this. Let me just show you again. Where is it called? Yeah. So this is the scenario where you have a try block, an except block, an else block, and a finally block. So there are 4 blocks: try block, except block, else block, and finally block. Okay. Try block, except block, else block, and finally block. So the code will first enter the try block. If there is no error, then the code will go to the else block and to the finally block, and then next rest of the script. So if from here error, if there is no error, it will go to the else block, finally block, and rest of the thing. So just see the flow. If there is no error, so first it executes the else block, then it executes the finally block, and then it exits the script, the particular block and rest of the script. Okay, so this is the way it works if there is no error. Now let us talk about the other scenario where there is an error. So if there is an error, it goes to this. Now there are two scenarios. The error is being handled by the programmer or by his script, or the error is not being handled. So if the that means error present in the list, I will explain what this means. So that basically now this means that error तो हो गई है, परंतु हमारे स्क्रिप्ट में उस एरर को डील करने का कोई अरेंजमेंट नहीं है. It's something similar to where the snake has bitten, but we do not have any anecdote to the particular breed of snake who has bitten the person. So what will happen there? The else block will not be executed. The finally block will be executed, and this will then exit, will stop the script, and the script will not move any further. Now somebody might ask that what is the need of the finally block? Once the error has already occurred and you don't know how to deal with it, your script doesn't know how to deal. What's the need of finally block? Now, in many, if you are doing advanced programming, the situation might so come that you are not able to handle with a particular type of error. But before you stop the script, you may like to do certain cleanups. Certain memory may have to be released, certain variables may have to be given up, certain other things may have to be done. So the script, the Python interpreter will give you an opportunity to do all those things in the finally block before it ultimately stops the program from executing. So I've talked about two situations. Situation one was when there is no error, and the situation two was where there is an error, but you don't know how to deal with the error. Now come to the third situation where there is an error and the error is present in the except block. That means we have got the anecdote for that particular snake bite. Then this will execute the finally block and then carry on with the rest of the script. So that means that if we follow this path, then the script will stop. But if we follow this path or this path, then the script, and this path, then the script will not stop, it will continue. Is this clear? Anyone?
Yes, sir. Yes.
Yeah, I just need to make a small message to somebody who's calling me again. Just give me a second, please. So ये clear हो गया, but this will become clear as we do an example. So let me come back to that script we were dealing with. So now basically for this, because I have to show you these things through examples. So मैंने क्या किया? मैंने एक ऐसा function create किया है जो तीन तरह की errors create कर रहा है. First error is the index error, which I have shown you. So this line of code was not executed. That is why this is not printed. Rather, and this took you here, and this index out of range was printed, except, and this was not executed, this was not executed, then this took you here, and this exception, this was executed. That is why we got the two outputs, that index is out of range, this is the first line, and exception of this will print is the second line. This is how it worked. Now let me do something different. Let me make it 3. So now there will be no index error, obviously, and the divisor, let me make it 0. Now let me run the program. Let's see what happens. So let me just so now let me just show you. Now I am calling this function again with these 4 variables. First is myl, which is ABCD. Second is index, which is 3, which is okay. Third is a dividend, which is 100. Fourth is a divisor, which is 0. So I enter the try block. If this is printed my L IDX, since this is an IDX of IDX of index of 3, so this will not throw an error. This line will be executed. That is why this line was executed, right? Okay. then we come, because my because an IDX of 3 will give you the D in the list. That is why this D was printed over here. Let me just clean it up. This has become a bit dirty. Let me just do it again. So when I ran this, I did my L was ABCD, IDX was 3, which means that the fourth item of this D would be printed. That is why this line is printed, and IDX is D. That is fine. Now comes to the second. So this line gets executed, no problem. Then the interpreter comes to this line. If this is printed divisor not 0, dividend upon divisor. So this line is not executed because if the divisor is 0, the Python interpreter will immediately throw an exception and the code will not execute. It will jump to this line. Except index error, print index is out of range. But this error type is not an index error. This error type is a 0 division error. So this line of code will not be executed. So Python interpreter will look for the next case, except 0 division error. This is the kind, can't divide by 0. That is why this got printed. The other else will not be printed. Then finally gets printed and the interpreter exits. This is how it works, right? Now let me show you the third type of error. So no, wait, let me just make this as 10. And now let me run this. Okay. So now what I have done? So I have taken care of this index, making it 3. So this line of code is printed. I have made the divisor to be 10. So this error will also not be there. So this error is also printed. And then I do something funny. I try to add an IDX, which is an integer with the value of 3. I try to add the integer to a list. This cannot do. So this will throw an error. Adding list to integer raises type error. But now what happens? The interpreter stops, goes to except index error, doesn't find it. Goes to 0 division error, doesn't find it. Then it cannot this. Then it goes to the finally block, exception or not, this will be printed. And then since the error has not been dealt with, then this error will happen. You can see type error can only concatenate list to list, not. So therefore, but suppose I'd put another except here. I'd put another, let me just copy it. Let me just copy it. I'd put another except here. And then I write print type error. Now what will happen? See, now what happens is that there is no error raised by the interpreter, because this error where I'm adding a list to an index, which is a type error, is taken care of by this block. And that is why this type error line gets printed. And there is no error by the Python interpreter. I can show it to you. I can suppose I write here print hi. Let me just show this. Let me run it again. So since this line of code is executing and this line of code is after this try except block, that means this line of code is executing. That means my script is working fine. There is no error raised by the Python interpreter.
Sir, I have a question, please. Can I ask?
Yes, please.
So in this, do we have to know the type of error which can be raised possibly? Like,
Yes. Yes, you have to know. But there is a way out. I will show you. I will show you. Now, if you do not mention any of these errors here, then also it will work. Let me just show you. So what is happening here is that since I have not given any name of the error here before here, so all errors will be caught by this except block. All errors will be caught by this except block. And now suppose I was to put this here, right? Let me run it. Must be last. Okay. So it will not allow me to put an except over here. This I cannot do. This except without an a type of error cannot be before one with. So I cannot put an except here, but I can put the except here after the zero division error. So I cannot this index error. I'll just copy it because I don't want to make any mistake. So I have to put this here. I cannot put except without the name of the error above the line of code where there is a name of the error. Does that make sense? Does that make sense? Yeah.
Okay, sir. Thank you. Thank you, sir.
Okay.
I just wanted to know that what if don't know the error names, then what
Then
will
you
happen?
then you do an except without the error will catch all errors.
Okay, thank you, sir.
So there is an advantage and a disadvantage of using except without the name of the error. What is the advantage? What is the disadvantage? The advantage is that you will catch all errors. The disadvantage is that you will not know the type of the error which has been created, which has been this thing. Therefore, except block will always, without an error name, should always be the last except. If you put it above others, in the beyond, there's in my book I write a topic called beyond text. So in the chapter on errors, there are exceptions. There is an example. If we get time, we will cover it also. So there I will show you that if you try to, let me just maybe I can just show it to you from the book. Wait. So I've given an analogy which is very interesting, so that should make sense. Yeah. Using an analogy to explain how parent exceptions and child exceptions work. Now you see in Python, everything is a class or an object. So even exceptions are classes, and just like you can derive your normal classes, you can subclass the parent class. The exception classes can also be subclassed. So there can be parent exceptions and there can be child exceptions. So in Python, exceptions form a hierarchy of classes. Moreover, exception of base or parent class will catch the exception of the child class. Like for example, in my case, we use the thing. So if you write except without anything, so this is an except statement which will catch everything, right? You can think of the analogy of a fishing net, where the parent class has finer holes than derived class has larger holes. So if you first use the parent class, which is analogous to a net with fine holes, it will catch all the fish, including which could have been caught with the bigger holes. Suppose you have a pond where you have fishes of all size, and you just want to catch maybe you want to catch the big fish. So you should not use a net with small holes, because it'll catch all the fish. So, but the better way would be to first use the net with bigger holes, catch whatever you can, then maybe use a net with slightly smaller holes, and then finally use a net which has very, very small holes, right? So the advantage of this will be that suppose you want to only catch fish which is more than 1 kilo, so you have a net of a certain size. Or maybe you want to catch fish with 2 kilos, then you have a net of a certain size. But suppose you want to catch all the fish, baby fish, small fish, large fish. Then you use the smallest. So your parent class is something like a net with very small holes. The advantage of using a net with small holes is that you will catch everything. The disadvantage will be that big fish, small fish will all come together. You may not be able to segregate them. That is what I've written. A wise fisherman will first use a net with bigger holes to catch only the biggest fish. This is analogous to using the exception class, which is at the bottom of the exception class hierarchy, or you can say the most derived exception class. So you should always start the except statement with the most derived exception class, then higher, then higher, then higher, and finally only except. That way, you will first catch the most derived exception, then the exception above it, then the one above it, and finally this. If, however, the fisherman just wants to catch all the fish, irrespective of their size, then he may use the net with finest holes. The advantage is that he will catch all the fish, but the disadvantage is that he won't be able to separate the big fish from the small fish. So, does this make sense? Yeah? Okay. So, let's come back to where we were. Okay. We had we have covered this, right? Okay. Using the let me just stop here for a second because let me just take some feedback from the class. Are we good so far? Uh, anybody wants to ask any questions? Any? There are no chats. Okay. So I'm okay. So let us move ahead. Using the try except block to read a file. I will come back to this topic once we have covered file reading, file handling in Python. Let's skip this point for a moment. Now let us come to user defined exceptions. User defined exceptions. In fact, we have covered most of this chapter. The other topics now are more advanced topics. So I'm not too sure whether I should cover them with you guys or not, but let me just try and give you a flavor of them, right? Okay. Okay. So user-defined exceptions in Python 2, there were two ways, was deriving from the exception class and deriving from the string class. In Python 2.x, we like to call it 2.x, 2.1, 2, 3, 4, like that. You could derive an exception class from the exception class or from the string class. But in Python 3, you can only derive an exception from the exception class. That means you can subclass the exception class. You cannot subclass the string class to create an exception class. Make sense or not? I don't know. Okay. So what does deriving exception from the string class means? Forget it. Don't read. If you want, those who are interested can read it in the book or do their own research on the net. So this was there in 2.x. It's not there anymore. It's not of concern to us. Okay, this is of concern. Nowadays, want to create a user-defined exception, you have to derive it inherently from the exception class or from a class which it has been derived from some exception class. All right. Okay. Now there's a piece of code I'll just show you, which yeah. Just look at this code carefully. So what I have done over here, I have created a class called myError. And this class is deriving from the exception class. That means if exception class is here, then from this exception class, I have created a class called myError. I've created a called myError. All right. So now what I'm doing, then this is the class definition like we did in the last class definition, simple class. Now I am entering a try block. So remember, this is not executable code. This is not runnable code. This code will only be, let me just speed it up. So in this code, the first line of code that will be executed will be this, not this, because this is class definition, not class calling or class creation or object creation. So I said print entering the try block. So this print will lead to entering the uh, try block, raise my, so now try block is not, see now note, this line of code also will not be executed. This line of code will not be executed. My error will be raised. Now my error is an error of the type here, this one. So here print raised, and once my error is raised, it will create an object of the my error class, and user exception will be printed. User exception will be, just let me do it again. Let me just clarify so that there's no problem. Now, when the try block is there, the try block will not be executed because there is an error. There is an error. There is an error, and this this user exception, the raised user exception is there, and then this, when I call this, it takes me here. It takes me here. It creates user exception. Then this entering the try block is printed, and finally the raised is printed. This might be a bit complex. Just do some research on your own also, and try and understand the flow of the script. So basically, I'll just show it you again. So basically, the flow is like this. The first line of code to be executed is by this user exception, which comes here, and then comes this entering the try block, and then this takes you to my error and raised. So if there's some confusion, just resolve it on your own. I've told you this thing. Let's move ahead. Any questions? Okay. Now there's another way of dealing with it. Now, I'll just show you. If you remember, in my previous code, I had no, this is not there. In my, this is not shown here, but here, what I was doing in this code, let me just, yeah. So here, what I am doing is, I am testing out the errors one by one, index error, zero division error, like that. I could have put all these errors together in a tuple. So I could have written except index error, comma, zero division error, close the tuple followed by a colon. So this is a tuple of errors. So instead of writing the errors one by one, I could have put them all together in a single tuple of errors. Is that clear? Let me just stop here for a second. Anyone? Any questions? Okay. So we are done up with most of the built-in exceptions. Let me just show you the hierarchy of exceptions. There's a small mistake in my this thing, this HTML. When I try to open it, it opens the same chapter 16. So what I did was, I copied this. You can just copy this here. Copy and then paste it. Right. So this is what I get. So as you can see, This website, it's given in my book here. It's given in my HTML, but it is not, the link is not working properly. I will correct it today, but the link is not working. You can copy and paste the link. It will take you here. So what does this show? Let me just show it to you. So there is a base exception. Now this base exception is the topmost class in the hierarchy of exceptions of Python. This in turn has got 4 children, 1, 2, 3, and 4. The first child is base exception group. The second is generator exit. The rather 5. The third is keyboard interrupt. The fourth is system exit. And the fifth one is exception. So let me just draw it again. So you may say that this base exception, this is the base class. It has got 4 children. This is child number 1. This is child number 2. This is child number, or rather 5, 3. This is child number 4, and this is child number 5. Exception. See, these 4, this one, this one, this one, and this one are really not important. The one of importance for us is exception. The Python documentation says that whenever you want to subclass the exception, you should not use base exception. You should not use this. 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 But rather, you may use this or one of its derived classes. So if that means that if you look at exception, then this has got further arithmetic error, assertion error, attribute error, buffer error, EOF error, exception group error, import error, lookup error, memory error, name error, OS error, like that. And then arithmetic has floating point error, overflow error, zero division error, like that. So this is the exception hierarchy. That means the zero division error is something like this. There is a base error. I think it was base error. This is subclassed by exception. This is subclassed by arithmetic error. And this in turn is subclassed by zero division error. So this is the way the Python hierarchy is working. So you can see down the line, there are so many value errors, warnings, like that. So this is the complete list of the complete exception hierarchy of Python. Is this clear? Yeah. Is this clear so far?
Yes, sir.
Okay. Any then okay, I'll give an example of a code of let us run this. This is a bit complicated. I should have written simpler code, but when I was writing the book, I don't know, somehow. So this I will write. I will do this for you guys. So maybe, okay. Let me run it. And output is there. Oh shit. Wait, I have made a mistake. No. Wait, I didn't copy the last line. I think, yeah, it's got left behind. Now it's okay. Yeah, now we are good. So let me just this is a very interesting piece of code which will help you to understand, clear up your concepts very well. All right. So basically, what is the code? There are 3 parts of the code. This is the first part. This is the second part, and this is the third part. In the first part, I am defining 2, or rather, I am creating 2 classes of class exception, class A and class B. The class A is getting derived from exception. So from exception class, I have created a subclass called A. And the class B is being created from A. So from A, I have created B. So the class hierarchy is exception, then subclass A, then subclass B. So B is at the bottom of this particular class hierarchy, and above B is A, and above A is exception. By the way, the PEP 8 documentation, I told you about PEP in case you don't, in case you've forgotten, that is the Python enhancement proposal. They advise that whenever you write the names of your own classes, you should use the word error. So ideally, I should have used this as A error and B error, so that somebody who is reading my script will understand that this is a class which deals with errors, and this is also a class which deals with error, but doesn't matter for the moment, that's fine. Now what I've done, there are two for, this is a for loop, and this is also a for loop. In this for loop, there is a local variable x, which will loop over a list containing two items A and B. A and B. And it will try and it will raise an exception. Raise an exception, raise x. And in the first instance, it will become AX. Let me just clear it out. So we are now talking about this, basically we are worried about this loop. So we are not discussing this loop. So this line will be printed. Then this loop will be entered. So in this loop will be executed twice. In the first iteration, x will be A. In the second iteration, x will be B. So when x is A, I will be raising A x. Right? And now this is raising an error of the type A. Now remember, the hierarchy was exception, then A, and then B. So when this error is raised, this will run to this except block, except B. Now, except B is an exception of the type B, which is a subclass of the type A. Therefore, this line of code cannot be executed in the first case. And therefore, this will be executed. Right? So in the first case, you will get catch A. And in the second iteration, you have a B. So it will raise BX. So this is able to handle this. So you will get catch B. So you will have two prints from this catch A followed by catch B. Let me just show you the output also. So basically, let me just actually thoda sa wo ja raha hai. Yeah. So what is happening? We are wait. Let me just. So as I told you, this is the first line of statement. This gets raised B before A. Remember now X is A. So I am raising AX. Now A is rather X, not AX, I'm raising A brackets. So this will not be caught because X is A. So therefore I'm getting catch A. So in the first iteration, I'm getting catch A. In the second iteration, X becomes B. This is able to accept B is able to cut, this will become, so I get catch B. So I get for this loop, I get these three statements: raise A before A, catch B. That's what happened from this particular loop. Now let us come to the next loop.
Sir, I have a query.
Yeah.
Sir, if we exchange the exception instead of B to A and A to B, so what?
Yeah, I've done it. Yeah. I've done it in the next. That's in fact, that is what is there. You have preempted me. So this is exactly what is happening here. So here I've done except A first and except B later on. This is just the opposite of what I did over here. So now except A has come before except B. Now remember, since A is at the top of B, A is at the top of B, so A can catch an exception of the type B. Therefore, if you put A above B, B will never be executed and A will always be executed. That is why you get, when I use it with A, I get this is raise A before B. This is printed. Then I get catch A. So it is catching A, that is fine. And when I raise B, also it is catching. So it is again coming catch A. So catch B is not getting executed. Does that make sense?
Yes, sir.
Yeah. So we have covered catch A, catch B. So I don't know.
It's a bit heavy, sir.
Though the next one is a bit more heavier. So do you want me to go on the next one? It's a bit exception object. Let me try. Actually, this is hardcore programming. This is actually not relevant for your syllabus. And as I understand, I was told this. No. Let me try. So let us. This is the thing on beyond textbook, the exception hierarchy. In Python, exception also have a class hierarchy. I already mentioned that. Study the hierarchy of the exception available at this thing which I showed you. After studying the class hierarchy of, you may realize the following. Number one, at the top of the hierarchy is the class-based exception. So all exceptions in Python ultimately inherit from this class. The four major are base exception are system, exit, planner, and exception. If you intend to create your own exceptions, it should be 5 rather not 4. This is 5. This is 5. Then you should subclass or inherit from exception class and never from the base class. No, by note, you can create a class of your own which inherits from base exception also. But the Python documentation says that you should not do it like that. If you want to create your own exception classes, your own error handling mechanism. In fact, if you read any of these standard libraries like requests, pandas, so they have many of their own inbuilt. They have their own inbuilt classes for handling with exceptions, dealing with the specific requirement of their programs. And all those classes invariably inherit from the exception class of the Python. So this is clear. So let us go ahead. This I have discussed. Yeah, the analogy I have discussed. Yeah. Okay. All exceptions are classes in Python. This already I've told you. Therefore, instances of exceptions are objects. Let us find out. Somebody's talking. I don't know who. So, okay.
Sir, you can unmute yourself.
Okay. So, now I'm moving slightly advanced. I'm talking about the error object. अभी तक हमने errors classes की बात की थी, but since you're talking about, so if you want to, you see in Python, as I told you, if you want to be able to see, there are two things: creation of an object and a reference to the object, or a pointer to the object, or a variable which points to the object, right? So whenever an error is created, you can create a variable which will point to the object. And the syntax for doing that is except, then your tuple of errors, and then you have to write as, and then you have to give a variable name. So once you do that, that means, let me repeat. So there are the keyword except, followed by tuple of classes, followed by the keyword as, followed by the variable name, which will be of your choice. So you can give any variable name which is permitted, followed by a colon. So if you do this, and this particular exception block is entered, then this error object variable will contain the error object, this error object variable, which I have named as error object, you could have made it EB, you could have made it E underscore B, whatever you want, you could have named it. So I named it error object. The error object will refer to one of the three error classes given in the tuple. Now, this error object can only contain one of these three. So if this tuple had 4, 5, then it can contain one of these 4, 5. And the lifetime of this error object is only in the indented block of the code following the except statement. That means this error object, let me just clear this code, this page. This error object will only exist in the block following the except statement. That means it will exist here. If you try to go outside this block and try to access this error object, it will not work. Because it's a local variable which exists only in the particular except block, right? Okay, so let me just okay. Let me just show again. As I told you earlier, I will never tell you something which I cannot prove with examples, right? So let me just show you this code. Okay. Just look at this code, because I presume most of you guys are new to Python, or maybe you have some basic exposure to Python. So maybe you're not so well. So what I'm doing, I'm having a try block and I'm having an except block. And I'm doing a simple x is equal to 1 divided by 0. This is zero division error, right? So what I've done, if I put as E, if I had not put this as E, then I will get a zero division error. That error will be dealt over here. That error will be dealt here over here, but I cannot access that error. Let me just show you. Let me just write this same code. Oh, wait. Suppose I was to copy it and then I was to put it here and I remove this particular line. Now, but this will throw an error because E is not defined. So this will not work. So like I can remove, if I remove this, then I'm okay. No. Let me just print. Let me just print high over here, and let me remove these two errors. These two prints. Let me run this. Okay, so this is working. So the difference, now let me show you the difference between this code and this code is that here the error object exists, but I cannot access it because I have not transferred that error object to a variable. Therefore, I cannot access that error object because I have not put as E or as something or as X or as Y or Z, whatever you want to name. But you should use conventions which are common in Python. You should not use words like X, Y, Z. You should use error or my error or ERR, something like that. But here in this code, I have put zero division as E. So the error which has been generated in this try block, that error object, it can be accessed by using the variable E. Does this make sense? So, yeah. So now let us see what happens. Okay. So let me just first let me bring the theory, then we'll come to the practice. Okay. This is the code which I was running in my example. And in the book it is mentioned E is an error object of class zero division error. It has one argument in the form of a tuple, that is division by zero, and also has a string representation. Therefore, if I type, let us Let us just one. Okay, so now just see. Now I'm having three print statements. Type of E is zero division error. Args of E is division by zero. And the string representation is also division by. I have not done string representation. Just accept it for the moment. We'll come back to this. In case this is not clear, just accept it the way it is. Let me just. I will just show you this. You can do on your own also. Yeah. Balaji, are you there?
Yes, sir.
Do you want me to do this traceback module? It's a bit advanced. I am just worried it should not confuse the students.
No, I think track back, just leave it.
Traceback module
The
is
basic one, it's a very advanced.
Yeah, you don't, because this is for those who want to go into the depth of why the
Debugging, high debugging, they want to do it, as a
Yes,
full-fledged programmer. Then only.
So I think that we should leave it here, right? And as it is 9 o'clock. So I think we can stop here.